Integration by parts. Here we're going to use the product rule. So what was it? F times g, the derivative of that is equal to f prime g plus f times g prime. Okay, let's integrate both sides. Dx, integral of that, and integral of that. So this one will cancel, so we're going to get f times g is equal to the integral of f prime g dx plus integral of f dot g prime of dx. Okay, so now we're going to let some things here. We're going to, instead of just doing the substitution, we have a couple things we have to take care of. So we're going to let u equal f, and we'll let v equal g. Okay, so du by dx is equal to f prime, and dv by dx will be equal to g prime. Okie dokie. Where are we going with this? Let's just solve for the dx's here. Or du here. So du is equal to f prime dx. Oh, I've seen that before. It's right here. Great. Okay, and then same with this one here. dv is equal to g prime dx. I've seen that as well right there. Okay. So let's substitute all this stuff in here, okay? So we're going to get u times v is equal to integral of, well, that guy can be said du, and g was equal to v, so it's going to be v du plus integral of, what was this one? This was dv, so, and this one's a u, so u dv. Whew. Okay. Let's just rearrange this. So we'll just solve for one of these guys. That's what we're trying to get to. So we're going to integral of u dv is equal to, bring this over. So it'll be equal to u v minus integral of v du. Whew. There it is. So we use this function when we use this equation when we have two different functions multiplied against each other. Okay, and there's ways to do it. You want to pick the v value for things that will get, or you want to pick the u value for things that will get simpler when you take the derivative. So you want to pick u's as maybe polynomials. Okay, so you want to use this as a polynomial. Okay, right? If you see it, because that will get simpler as you take the derivative of it. Du will get simpler, and the v's can be something that switches back and forth. They can get a little more ugly, but you want to definitely have these as the polynomial. So what you need to pick here is you need to pick the u function, and then you need to pick your dv function. You need to pick this, and then you integrate this here to get your v. You differentiate your u to get your du, and then you substitute using this equation. And you're going to end up with another integral, but hopefully it will be simpler. Because, like I said, if you pick a u that will get simpler with derivatives, like a polynomial, like x squared, d by dx of x squared becomes 2x to the power of 1. And if you take the derivative again, it becomes 2. It becomes simpler. So when you take this a couple times, you will get a simpler integral. These are messy, but it is a way to solve an integral.